Here is the question that separates junior engineer from architects. Why can't your EC2 instance connect to the internet? You have got a VPC, you have got subnets, you even attach an internet gateway, but your application still can't reach the outside world, and you have no idea why. This is the VPC knowledge gap. Most tutorials show you how to create VPC in the console, but nobody teaches you how to architect a networking that actually works in production. So today we are fixing that. By the end of this video, you'll understand the exact blueprint that powers AWS infrastructure at scale. Hi, I'm Pratik Kumar Mohite, a cloud DevOps professional, and I built this channel for one reason: to help you think like a cloud native architect. Before we architect anything, let's establish three fundamental truths about VPC. Truth 1: a VPC is your private data center in the cloud. It's an isolated network where your resources live, complete control over who comes in and who goes out. Truth number 2: subnets are your availability zone strategy. Every subnet lives in exactly one availability zone. This means your subnet design is your high availability design. Truth number 3: routing tables are the traffic controllers. They determine where network traffic goes. Get routing wrong and nothing works, even if everything else is perfect. Here is what we are building today: a production grade VPC that handles high availability, security layers, internet access, and cost optimization. Let me show you the final architecture and then we'll build it step by step. For free tier, check the link in the comments to start with your free tier account. If you are having issues with the creating free tier account, do let me know in the comments so I can help you with that. Here is the complete architecture. You'll want it as a reference. The layer 1 VPC foundation, where the CIDR block are 10.0.0.0/16, which eventually gives you 65,536 IP addresses. Region AP South 1. I'm using Mumbai region, so you can use any region which is closest to you. Layer 2 availability zone strategy. 2 availability zone minimum, AP South 1A and AP South 1B. Why? Because if one availability zone fails, your application stays online. AWS guarantees 99.99% uptime only when you architect across multiple availability zones. The layer 3 subnet design. In each availability zone, we create two subnets: public subnet, which is the internet facing, AZA, which has CIDR 10.0.1.0/24, AZB has 10.0.2.0/24. So this is for the public resources like load balancer, bash and host, and NAT gateways. Private subnets, which is protected, AZA, which has CIDR 10.0.11.0/24, and AZB has 10.0.12.0/24. This is for your private resources like application servers, databases. Layer 4 internet connectivity. Internet gateway. It enables the internet traffic for the public subnet. NAT gateways, one in each public subnet. This allows private resources to reach to the internet for updates and API calls, but prevent inbound connection from the internet. Layer 5 is the route tables. The public route table will have 10.0.0.0/16, which is for the local traffic, and all the other traffic which will go to the internet gateway. Private route tables will have a same thing, but instead of going to the internet gateway, it will go to the NAT gateway in the same AZ. We use separate NAT gateways per AZ. Why? So if one availability zone fails, the other availability zone's private resources still have internet access independently. Theory is done. Let's build this in the AWS console. When you log in, you will see the AWS dashboard something like this, and you'll search for VPC. In the VPC dashboard, click on Create VPC, select VPC and more. Name the VPC as Production VPC for now. The CIDR, mention it as a 10.0.0.0/16. Number of availability zone are 2. The public subnets are 2 and private subnets are also considering as 2. The NAT gateway is 1 per AZ and the VPC endpoints none for now. AWS automatically creates subnet, route table, internet gateway, NAT gateway with this proper configuration. NAT gateway cost approximately $0.045 per hour plus data fees, and it's about $32 per month each For production, this is worth. For testing, use one NAT gateway or terminate when not in use. A NAT gateway's cost varies by region. Click on Create VPC. It takes about 2 minutes to create it. Never trust that AWS configured everything correctly. Always verify correct CIDR blocks, write availabilities on assignments, auto assign public IP before enable for public subnets only. For route tables, public route tables should have all traffic going to internet gateway, and private route table should go all traffic to the NAT gateway. Verify internet gateway attached to the VPC and NAT gateways. There are two NAT gateways should be created in the available state and one per public subnet. Common mistake. Ensure private subnets are not associated with the public route table. If they are not actually private. You have got a working VPC. Now let's talk about securing it and optimizing the cost. Security best practices. Enable VPC flow log immediately. It will capture all the IP traffic. Store in CloudWatch or S3. Essential for debugging and security audit. Security group strategy. Layer your security group. If it is a web tier, it should allow 443 from anywhere. If it is the app tier, allow the app port only from the web tier security group. And for the database, allow the database port only from the app tier security group. Reference security groups, not IP addresses. This scales better and is more secure. I will cover this in the upcoming videos. Minimize the public subnet. Only put resources in the public subnet if they are absolutely must be internet accessible. When in doubt, go private. In the cost optimization for non-production, use one NAT gateway. Development and staging don't need the high availability. One NAT will save $32 per month. VPC endpoints save money. For AWS services like S3 and DynamoDB, use VPC endpoints. They are free and keep the traffic to the AWS private network instead. And we will discuss this in the upcoming videos. Right size your CIDR. Don't use /16. You will never exceed 1000 instances. A /20 network portion gives you 4096 addresses, which is sufficient. This production architecture cost approximately $65 to $70 per month for networking alone. For learning, scale it down. Let's recap what you now know. You understand why VPC are designed this way, not just how to build them. You can explain multi-availability zone architecture for high availability, public versus private subnet strategy, internet gateway versus NAT gateways, routing table logic and traffic flows. More importantly, you have a reusable blueprint. Every production VPC you build will follow this pattern. What's next? In the next video, we'll settling the debate of security group versus NACLs, which is a network access control list, and when to use each. We will deep dive into stateful versus stateless filtering, the rule evaluation order, and when NACL actually makes sense. It's the missing piece to complete your VPC security strategy. Before you go, what's your biggest VPC challenge? Drop it in comments. If this video gave you a deeper understanding of AWS networking, subscribe to Cloud Native Labs. We release production-focused deep dives every week. Now go architect your VPC. The blueprint is yours. This is Cloud Native Labs. Let's architect system that scale one service at a time. See you in the next one. Happy learning.